Thanks, everyone. I am a professional and amateur astronomer, and as Bridger says, what that means is that I get paid to think about, stars and black holes and stuff. But I also spend a lot of time out under the dark sky. I have telescopes. I spend a lot of time doing public-facing stuff, which includes talks, but also star parties and teaching people about the sky as part of their lives. Astronomy is one of those things that almost no one despises, and so it kind of helps everyone kind of think about our place in the cosmos and think about what we're a bigger part of, and astronomy is just kind of a good thing for that. So I always enjoy going out and talking to folks, and it's always a special opportunity to come here to the Mattel Valley because we do a star party as well, and so that's a lot of fun. I grew up here in the Pacific Northwest. I grew up in Oregon. My folks are from La Grande. So I'm a graduate of La Grande High School. Any Grand Ronde Valleyans in the room? Anyone from Northeast Oregon? Nope? Okay. I'm an Oregon State graduate. I got my bachelor's at Oregon State, and I did my PhD at Montana State. So I'm from the West, but I live in Chicago now. And so the reason I come back every summer is because I live in Chicago now. So I come out, and we camp, and we see the dark skies, and we enjoy ourselves. So I have my telescope with me, and we'll do this. So it's a great pleasure to be here, and I certainly want to thank the Conservancy for inviting me back, and the Tap House for sponsoring again. They sponsored us last year as well, and we'll have some fun, okay? So I am going to talk about the night sky, and I always talk about astronomy stuff. I'll tell you a little bit of science just to get everything primed up as we go along, but the preservation of the night sky is something that I think is deeply important to us both professionally as astronomers, but also to those of us who do astronomy as a hobby and as part of our kind of everyday lives in our own backyards. And certainly in my lifetime, and certainly in the places I live in, I have seen the night sky begin to disappear. And as astronomers, we are seeing impacts on our ability to study the universe and do the science that we do because as a civilization, we're not careful, or at least we're not being careful enough about how to preserve this natural resource. And so the framing tonight, as Bridger said, I think really is that. I want you all to walk away from this talk thinking about this the same way you think about energy, the same way you think about water, the same way you think about wildlands, anything that we're trying to preserve that is here before humans had impact on it. And so how we balance that with the needs and the desires of our modern civilization is kind of what the game is all about. So I'll talk a little bit at the beginning about science and why it's interesting. I'll talk a little bit about what the problems are, and then we'll talk about things that we can do. And certainly I'll have a few things to point you towards the Dark Sky Coalition at the end. Okay? So a couple of things here. This is my blog, writescience.wordpress.com. That is a public-facing blog. I write about all sorts of sciencey things there. It's mostly so my mom knows what I do, so it's supposed to be understandable. There's lots of stuff about black holes and gravitational waves and exoplanets and that sort of stuff, but there's a lot there about amateur astronomy and dark skies and what you also can see from your backyard. So you may enjoy some of that. There's my email address, okay? There's a period there that looks like a star. Don't forget it. That is there because you'll have some questions. I'll answer questions tonight as much as we have them. But invariably, you're going to wake up 2 weeks from now in the middle of the night, and you'll have some question, and you'll be like, oh, I wish I had an answer. And at that point, you can email the folks at the Dark Skies Coalition, or you can email me, and I'll do my best to help you find an answer. Okay? Most of you know at this point your spouses don't want to wake up at 2 in the morning and talk to you about astrophysics and astronomy. So just email me. It'll be much better for you. Okay? Okay, and then you can certainly follow me on social media if you're interested. So my opening slide here, and throughout the talk there will be lots of astrophotography. This is one of the beautiful things about the age that you and I live in. The technology to capture images like this is in the hands of people like me and you, and there are lots of people who make this their hobby, and it is quite spectacular what they can do, and of course they share it so we can all find it. So where I have been able to deduce who created the images, I've certainly put their names down there at the end. Okay, but you'll see a lot of this, and in particular for this version of this talk, I give this talk a lot. I tried to draw it all from the North Cascades and the Mattel Valley, so some of this will look familiar to all of you. Okay, so If you grow up in the West, certainly. This particular one, this one's in the Grand Tetons, actually. Yeah, so this one in the Mattel Valley. Yeah, it is the Tetons, yeah, that's right. And I forget the name of the lake, but yeah, this one's in the Tetons. Okay. If you grow up in the West, and certainly I grew up in the West, the way I was originally exposed to the night sky was camping. My folks would take me out all the time. My mom was a forester, my dad was a plant ecologist, and so we'd go out and do field work all the time, and for weeks on end. And we didn't have a telescope, but my mom had a little birding scope, the kind that you can look at, Canadian geese, because you've never seen a Canadian goose before, right? So we'd take that out, and I'd look at the moon, and I'd look at the planets, but you would just constantly immersed in this gigantic vault of stars over your head. And this is something that's very familiar to those of us who grew up in the West. In the East, I meet folks all the time who have never left the city of Chicago or never camped farther than 100 miles from Chicago, and they've never seen skies as pristine as we're familiar with here in the West. And that's kind of one of the things that makes this hard often to talk to people about, because when you're exposed to this every single day, you don't realize how precarious our handle on preserving the night sky is. Okay? So I want you all to kind of think about that and keep that in the mindset, because I'm sure there's many of you in this room who have been in this kind of situation. I should ask before we go, are there any professional astronomers in the room? And how many amateur astronomers? Okay, a couple of you. Okay, and so everyone else is like, I see the stars when I camp, right? Okay, is there anyone who's like, what's a star and what are we talking about right now? Are we good? Okay, so we're basically talking to folks, right? This is new for all of you. That's important for me to know. Okay, so we'll talk a little bit about the night sky. I'm going to tell you some of the things that I know you can see from right here in the Mattel Valley. I'm going to tell you a little bit about the science of them, because it's awesome, and just kind of to set the framework of why we're trying to preserve skies at all. We'll talk about light pollution. Generically, that's the problem right now. We are polluting the skies with light. Okay, and then at the end we'll talk about how to help. What kinds of things can be done to deal with this. So this is right here. The very first image that came up when I started Googling for astrophotography in the area was this picture up on Washington Pass. This is actually my favorite one of all the ones that I found. But what I discovered is that there's a whole sequence like this from a variety of photographers that all kind of look the same. Right? They're all from the same viewpoint. They're all of the Milky Way over the mountains, and they all have the highway here winding up the mountainside. So I can only guess there must be a vantage point that's easy to get to. See, all of you know, right? Okay, where is it? And you can just stop. Okay. Right here? Okay. Okay, so you all know that your modern phones, the phones you've bought in the last 5 years, are perfectly capable of taking pictures like this, okay? These are all 35 millimeter cameras, right? But your phone can do this. So go hang out that overlook, all you locals know where it is, and you can get pictures just like this, right? So I'd have to know when they took it to know, but when it's that bright, it's almost certainly Venus or Jupiter, one of those two, right? Okay, so the reason I showed you these pictures on Washington Pass, though, is because one of the things you can see here in the West, and in particular here in the Mattel Valley, is you can see the Milky Way with your naked eye. And it shows up way better in images than it does to your eye. You'll never see this kind of color with your eye. Okay, but you can see the Milky Way. And I bring people from Chicago with me all the time out here. And when the Milky Way first starts to come out, it's so bright, it looks like a cloud. And they're like, oh, we're not going to get to observe tonight. I'm like, what, are you kidding me? That's the Milky Way, right? So what is the Milky Way? Does anyone know what the Milky Way is? It's our galaxy. It's our home galaxy. We live inside the galaxy, and so we can't see the galaxy the way you're taught about it in school, because we're basically inside a pancake looking at the pancake edge on. And so all you see is this river of light, this long swath that stretches from one side of the sky to the other. So tomorrow morning, hold your pancake up edge on, and when someone asks you what you're doing, saying, I'm pretending I'm in the Milky Way, because you are. Okay? So this is what it looks like. So as astronomers, one of the things that we've been doing is we've been mapping out 1 billion stars in the Milky Way. So there are like 400 billion stars, but we're mapping out 1 billion of them to know exactly what the shape and how the galaxy is changing and evolving. And so this is the image created from those billion stars, and it looks just like the Milky Way that you and I can see in the sky. It's a swath of light made by 1 billion stars, each one of which is too small to individually see on its own, but when you put 1 billion of them together, it creates enough light that you can see when you stand out under a dark sky in a place like the Matau Valley. Okay? If you could actually fly into it, you would see that that fog would resolve itself into individual stars. And if we could actually swoop out of the galaxy, fly through the galaxy like we're a bird flying through the valley, you would see that spiral structure that you're taught has those spiral arms that we're taught the galaxy is made of, swirling around this very bright center that we call the bulge. And the sun actually lives out here on the outskirts. Okay? When you're living in the pancake, you literally are in the middle of the pancake looking through it at that swath of light you see in the sky. Okay? There are people who have never seen that. Okay? And most of you can walk out in your backyard here and you'll see it on any given night. Okay? There are other cool things you can see. So this is taken up at Ross Lake. This is the Aurora Borealis. How many of you have seen the aurora? How many of you have seen the aurora this year? Oh, a few of you. Okay. Okay. So there are many places here. This is another one by the same guy up on Maple Pass. I went hiking up here last year during the day and like, oh, I need to go at night now so I can see the aurora. This would be fantastic. What I was telling you about the phones is absolutely true. Okay. The phones that you have now are capable of capturing the aurora. And so right now, the sun is getting active. I'll show you in a minute what causes the aurora. And so lots and lots of aurora pictures are showing up because you have the technology in your hand to capture it. Okay? And when you live in a really dark place, like you live in here, the opportunity to see the aurora occurs often and regularly. You can get apps on your phone that will warn you, and then you should take the chance to go out and certainly look. And if you get up high like this, you can get these kind of spectacular pictures like this. So where do aurora come from? Aurora come from the sun. So this is a picture of the sun. The sun is a very turbulent, active maelstrom of plasma, as we call it. The scale of the Earth on this picture is about the size of this spot. Okay, so you can see these enormous solar eruptions are many, many times the size of the Earth. And what happens is those eruptions throw crud, plasma, electrons, particles off of the sun, and it flies towards the Earth. And when that happens, when it flies towards the Earth, all of that stuff from the sun comes into the Earth's atmosphere. It hits particles in the atmosphere, molecules. And those of you who remember your chemistry and physics class may remember that when you smack a molecule, it gets excited, which means it sucks in some of that energy that it got hit with from the particles from the sun. And molecules hate being excited. Okay? And so they want to calm down. They're very good at being zen, and so the way they calm down is they emit light. And that light is what you see as the aurora. Okay, so when the sun's in this state, it's just showering the Earth with these particles. All of these particles at different heights in the atmosphere are getting excited, and then they release light. Okay, and so you get these colorful bands of the aurora, okay, and those colorful bands all tell you what kinds of particles you're seeing all of the aurora come from. Okay, so the thing we see a lot of is green, particularly at these latitudes. That's all coming from oxygen. But when we have a particularly strong event, then you will see all of these, even down here in the Matau. Okay, so the sun goes through this cycle every 11 years. It gets quiet, and then it gets stormy, and then it gets quiet, and then it gets stormy. So it was quiet in 2019. It's going to be at its maximum storminess in 2025. Okay, so between now and about 2027, there are going to be lots and lots of chances to see the aurora from dark places like the valley. Okay, so you should keep your eyes open. Okay, it is not possible to see the aurora from places like Seattle because they have way more light than you guys, right? Okay, that's the game. Okay, the other thing, when most of you know this when you go out camping, is just the sheer number of stars that you can see in the sky. We tried to promote astronomy in Chicago. My colleagues at the Adler Planetarium, which is the oldest planetarium in the Western Hemisphere, they have counted the number of stars we can see from downtown Chicago. It is 7. Seriously? 7. Okay? Now, all told across the whole sky, there's something like 9,000 stars that are visible to your naked eye. And if you just go out camping here tomorrow night, okay, you will see uncountable, huge numbers of stars in the sky. And if you learn your constellations, how many of you know your constellations? Okay, a few of you, right? Okay, it's really, okay, that's fine. That's knowing your constellations. If you learn your constellations in a place like this, it's actually really hard because you can see more stars and your brain is very good at making patterns that aren't the patterns you see drawn in the books, right? And I remember, because I learned my stars, in La Grande, Oregon, right? And the first time I went to a really dark spot, like out here, it's like, wow, there's more stars. I can't even recognize, the constellations I'm used to, because I'm like, what is that square? I've never recognized that square. Oh, well, that's part of the constellation I know. There's just a new star that I couldn't see. Okay, so in this picture here, there are constellations you are familiar with. Okay, and so when you go out in the dark and you observe, we'll do this on Friday night for any you come out with us. Most of us kind of anchor our evening around a constellation we can find, and we navigate from it. And when I'm at the telescope with you, I'll be like, we'll start here, and then we navigate from it. So it's kind of a milepost that helps you navigate. So in this picture, the constellation that I'm going to navigate from is Cassiopeia. Does anyone see Cassiopeia on here? Yeah, some of you do. The amateur astronomers are like, yeah, I totally see it there, because they're used to observing. Okay, so Cassiopeia is right down here. Okay, it's kind of a W shape. Okay, it's the queen, and that automatically makes you think of W, right? So it's Cassiopeia. Okay, but it's supposed to be her throne, so she's sitting on her throne there. So that's why it's that W shape. Okay, so if you navigate from Cassiopeia, if you go out and if you can find her, it's in the kind of northeast part of the sky when it gets dark, around 10:30 or 11 right now. If you just go upward here, the Milky Way is not very bright in this part of the sky, but it's getting brighter as you go up overhead. And you will see, you can kind of see it in this image, the Milky Way starting to appear. But right in the middle of it there, you'll see a little bright spot, which to your naked eye will look like a little cotton ball. Okay, but if you put a pair of binoculars on it or a spotting scope, that's actually something that we call the double cluster in Perseus. It's 2 regions of 100 or 1,000 stars that were all born together. They're all in the same place, and they're close enough together that it looks fuzzy to your eye, but when you put a pair of binoculars on it, you can see all the young stars hanging out together, like all of you hanging out here in the room, right? Okay, so that's a great thing to do with binoculars. We try and look through it with telescopes, but the telescopes zoom in too close, so it's actually really good in binoculars. Okay? But the reason I showed you this picture is because there's another fuzzy object in this image. Does anyone see it here? Yeah, right here? Yeah, okay. So that one right there, that is the most distant object in the universe that you can see with your naked eye. And if you go out in the dark here, you will see it up there. You'll be like, what's that fuzzy thing? Okay, and it's actually the Andromeda Galaxy. Okay, it's 2.1 million light years away. So if you and I go out on Friday night, if you can go out tonight and see it yourself, but if we go out on Friday night and we stare at it, the light that we see that night has been traveling for 2.1 million years across the void between the galaxies until it got to me and you here in Washington. Okay? Andromeda is awesome in that way because as amateurs and people who don't do astronomy all the time, it's a milepost that helps you really think hard about how big the universe is and how small we actually are. That kind of, what do you want to call it, disconcerting relationship with the cosmos is part of the spiritual nature of doing astronomy. And so thinking about things that are tremendously distant kind of help put in perspective what what we're doing here on Earth. But as astronomers, professional astronomers, the Andromeda Galaxy is singularly one of the most important objects in the sky. So this is an astrophotography view of it through a telescope. This one's by an amateur. We have similar ones that we've taken with Hubble. But this year, October of this year, is the 100th anniversary of the discovery of the first star in the Andromeda Galaxy. Okay, so that was made by Edwin Hubble. Okay, and the reason that's important is because that discovery allowed us to measure the distance to the Andromeda Galaxy. And it was the first time we understood that the universe was vast beyond the size of our own Milky Way. And that led directly, 5 years later, to the discovery of the expansion of the universe. Okay, so for modern astronomy, this was the beginning. And so it holds a very special place in our mythology and our folklore about how we came to understand the universe, because this happened. And it happened within memory, right? How many of you know some centenarians? Anyone? Anyone here over 100? Okay. Okay, well, my great-grandmother was born before this happened. Okay, so she lived through the discovery of the universe is tiny to OMG, the universe is huge. Okay, and it's because of this galaxy. And you can see it standing in your backyard right here in Twisp and Winthrop. Okay? So, this is the game. Okay? And because it's so dark here in Washington, the reason I come to Washington every year is there's a very famous star party called the Table Mountain Star Party. It used to be down by Ellensburg, and in 2015 there was a fire, and so they don't let us go there anymore because it's not recovered yet, and we've been doing it up near Oroville now for the last 6 or 7 years. It's going to move. Yeah, right, there's a fire now. Right, exactly, yeah. So they're looking for a new site again. Lots of the folks from Seattle come over. We come from Chicago every year for it. And it's because the skies here are so dark. And we can stand out there and with our eyes and with our telescopes see all of these things that I've been telling you about, okay? We could do this all night. We could do this for a week. We could come every night for a week, and I could tell you cool things that we could see in the sky, okay? But we're not going to do that, okay? Because I want to tell you about what's happening and how this is becoming a very precarious natural resource, okay? So you and I live in the space age. Everyone in here grew up during the space age. And one of the products of the space age is really awesome pictures. This is part of a much larger picture called The Globe at Night. This is just focused on the United States. And what you see here is produced from satellite image, a picture of what the United States looks like if you just point the cameras down. Okay? And what you see is there's lots of lights pointing up at the satellites. Okay? So the United States, every point here is a city. Okay? Here's Chicago, where I'm from right now. Okay, over here in Washington, there's Seattle. Okay, in the Midwest, this must be Minneapolis, I guess, right? There's a whole bunch of Miami Beach down here, right? There's center of Texas, that's Dallas. Okay, so New York, right? The whole New York, Philadelphia, DC corridor there. Okay, there's lots and lots of lights. Okay, but every one of these little specks of light is also a city. Right? So LeGrand, Oregon, you may not be able to see it from where you're sitting, but where I grew up, LeGrand is right here. I think it's this one right here. Yeah, so, okay? So you go up from Boise, you go through Baker, you get to LeGrand, you get to Pendleton, there's a series of 3 dots. That's where we are, right? Okay? So every city in our country is projecting light up into the sky, so much so that you can see it from a freaking satellite. Okay? So let's zoom in on Washington. Okay? So this is just the state of Washington. Okay, so I'll put the big cities on there to help orient you, but you could kind of guess it. This is Vancouver, BC. This is Vancouver Island here. Okay, but here's the whole complex of Seattle. Here's Portland and Vancouver, Yakima to Tri-Cities, Spokane all the way over to Post Falls and Coeur d'Alene here. Okay, but once you orient yourself, you can pick out the smaller stuff. So the brightest things close to you are Okanagan and Wenatchee. Okay, and if you know all the cities along here, you can pick them out. But right there are Winthrop and Twisp. Not a terrible lot of light here, but there's Winthrop and Twisp. Okay? Now, if you look, though, look at all the spaces between all the cities, and in particular up here near Winthrop and Twisp. It looks like it's dark, okay? And in some of the places it is, okay? But the lights pointing up aren't the only issue. The real issue, these are all just like going outside in your backyard with your flashlight, and when you see the satellite flying over, shining it at the flashlight, okay? The city's doing that no matter what. But light pollution is more than just shining a light straight up. Light pollution is the fact that that light that you shine in any direction gets spread around. Okay, so we call that diffusion in physics. So this is the classic example. You can see it here in the room, okay? But this is just in my living room, right? If you take the lampshade off of a bulb, right, you get this very bright, sharp light. It casts really harsh shadows. There are places where you'd like to have light, like right here at the headboard, right here, and the light isn't very good there. And so the way we do that is we put a lampshade on it, and it takes this very harsh light, and it softens it, and it spreads it in every single direction. So there's no place where there's a ton of light. There is above and below because there's a hole in it, right? But it kind of evens out the illumination and spreads the light around. That's what these bulbs on top of the lights here in the room are actually doing, okay? The same thing happens. How many of you work in offices or buildings with fluorescent light bulbs, right? They have these plastic diffusers over them, but if you take them off, it's the same deal. It's this harsh glare, very localized to where the fluorescent bulb is, okay, and you put the diffuser on it to spread the light around, okay? Well, nature does the same thing, okay? So anytime there's light, all of the dust, all of the moisture, all of the smoke, all of the clouds, right? Anything in the atmosphere grabs the light that we are spreading around our cities, and it spreads it around. Okay, so on a clear night, in fact, you can do this tonight when you step out when it first gets dark. If you just look towards any of those large cities, you will see a little light dome, as we call it, on the horizon. Okay, and that is because light is being shed by our civilization, but there's stuff in the air. And nature is perfectly capable of doing what we're doing with all of these diffusers on the lights. It takes the light and it scatters it around and smooths it out so that it's everywhere. Okay? It's particularly prominent when there's clouds. So this is a picture looking from my old house in Utah, but this is the city of Logan when there's a thunderstorm in the area, right? And so you can just see how much light is making it up onto the clouds. Nature knows how to diffuse light if you put it out. Okay? So when we talk about light pollution then, this is actually what we're talking about. The source of light pollution is individual lights. We'll talk about that in a minute. But this is what the fundamental problem is that nature's very good at taking that light and spreading it around. So we call, when you talk to amateur astronomers and you talk to the dark sky, we usually call these light domes. They're domes of light over our cities that you can see from really far away, right? Okay. So if we're going to deal, right, we're scientists, right? If we're going to deal with this, we need a way to quantify it. Right? You can see it with your eye, but you need a way to say, how bad is it, and what's the source of the problem, and then how can we deal with it? Okay, so we invented a scale to measure all of this. Okay, so this is back to one of our gorgeous Milky Way pictures. Okay, so this is by a guy named Royce Baer. Those of you who follow astrophotographers, Royce is an absolutely outstanding astrophotographer in Utah. If you're interested in this kind of photography, he has a nice little book that he's written about how to use your DSLR to do this kind of photography. But he has taken one of these images, and he's shown in this single image how light pollutes the image and what you can expect with different levels of light pollution, different levels of this diffusion, this scattering, depending on where you are, okay? So frame this in your mind, okay? And if I overlay the changes here, okay? So this is called the Bortle scale, okay? So this is what I have in Chicago, okay? So this is Bortle 8 or 9 skies. It's completely light polluted skies, okay? And over here, I'll show you in a moment, these are the kinds of skies you have here in the Mentau Valley. You have Bortle 1 or Bortle 2 skies, almost no light pollution. Okay? And then in between, there is a gradation that's related to how much light your community is throwing out into the sky. Okay? Now, there's a lot of technical detail behind this. There are instruments. I'll show you instruments that you can use to measure it. You can do it from your smartphone now. There are ways to just estimate this yourself. Can you see the Andromeda Galaxy? Can you see the Milky Way? Those sorts of things, okay? So if you want to be very adept, right, most of us, I have a little card in my observing journal I carry around with me that helps me, no matter where I am, figure out what the Bortle scale of the skies are. And collecting that kind of data is part of the beginning of trying to understand how are we going to combat light pollution and how are we going to preserve this natural resource that we call the dark. Okay? So this is the Bortle scale. And so it's color-coded here, and the reason I'm showing it to you right now is I'm going to show you the light pollution map of the state of Washington. Okay? And it's not just the little pinpoints of light that mark where the cities are. That's the takeaway. Okay? But the colors on the map are the Bortle scale here. Okay? So let's start with the state of Washington. Okay, so this is just the standard topo map. We are right here. Okay, so Twist wasn't marked on the map, sorry, but I put it there. Okay, and so what I'm going to do now is I'm going to put the Bortle map scale down. So we've gone through, we can make the same kinds of measurements that the satellite pictures make, and we can measure the diffusion of light across the entire state. Okay, so this is what the Bortle map of Washington looks like. Okay? Everywhere on that satellite image was one of these red or yellow dots, a city, a bigger city. Not a giant city, but a bigger city. Okay? You can see here's Winthrop and Twisp right here. They're blue. Okay? But all of the space in between is not dark. Light is diffusing outward from our cities because the city boundaries are growing, and in particular because all of us are moving out into the spaces between the cities. Okay? And so the actual distribution of dark skies, truly pristine dark skies, is only these black regions that you see on the map here. And so here in the state of Washington, out in the sagebrush land, there's some dark skies. Okay? And right here in the North Cascades, there's a lot of dark skies. In the wilderness, yeah. So the Pasayten Wilderness is up here, North Cascades is here, but the entire Mattal Valley is up here in this area. So the park is right here on the edge of this dark sky region. Okay? So there's Twisp and Wenatchee and Okanagan. So you live in the middle of one of the most pristine dark sky places left in the country. Okay, and it happens to be a beautiful place, right? Which is attracting people. And so all of us come here all the time, and that means that there is a distinct threat to this kind of pristine darkness that we enjoy when we live in places like the Mattal Valley. Okay? So the question is, what's going on and what do we do about it? The fundamental problem is how we create and how we use light in our communities is very ineffective. We just create light, we create it in copious amounts, and we do whatever we could have figured out, which a third grader could figure out, to put it where we want it. And we don't think hard about what the consequences of that are. So you look at cities, so this is, I think this is Los Angeles, okay? And you just get up on the hillside looking out on it, and all of those lights are pointing up at you. That's why you can see them. And when I put a light up down here in my neighborhood, my goal is to illuminate the side of that mountain over there. Right? Yeah, right, yeah. But we don't think about it. It's easy, so we do it, okay? You've all experienced this. Street lighting in particular in most cities is the source of a ton of this. So it's getting better and it's changing dramatically as our lighting evolves towards LEDs. We'll talk about that in a few minutes. But this kind of putting big lights on top of tall poles and then having the light shine in all directions is a large part of what you see going on in pictures like this. Okay? So there is a ton of terminology that goes along with this. And we, just like we could have a lecture every day about astronomy for a week, we could have a lecture every day about light pollution for a week and talk about all the different nuances of that. And I don't have enough time to do that with all of you, okay? The Dark Sky Coalition folks would probably sit with you every day for a week and talk to you about it, okay? But there's a lot of issues and there's a lot of different things. And so the goal here today is to just help you understand what the source of the problem is, give you a few contact points of things you may have experienced, things you may have seen, things you may know may be going on in your own neighborhoods or your own cities or your own neighbors and homes, and then provide that as a starting point to start thinking about this at the level of your community, okay? So I'm going to tell you just a couple of things. There's way more to it than what I'm going to tell you, but I'm going to give you a few starting points, and they're the ones that you hear us talk about most often, okay? And so let's start with this image, okay? So this here is what we call glare, okay? It's not glaring like your mother glaring at you, right? It's glare like, oh my gosh, I have to squint because I can't look at that thing because it's shining light in my eyes, okay? And you probably don't have as much of this here as I have in Chicago, but driving down the Chicago streets is really hard because these things are shining at me constantly. I have to wear my sunglasses at night to drive around Chicago, okay? So glare is any light that travels sideways or upward, okay? It's not being put down where you want it, on the street. It's actually going in different directions, okay? And you can subdivide glare into different parts, but generically, this is all glare, okay? And the problem is we want light on the ground, okay? We don't need it sideways. I don't need to see this light way down here when I'm half a mile away. I want that light to be on the ground. And there are ways of effectively doing it, but we haven't been careful in the way that we design lights and the way we lay out our cities and the way we illuminate them. Okay? For those of you who start talking to your neighbors about this and you don't have slide decks, the best way to show glare is to get your mag light. Okay? And these little mag lights, if you take the top off, it lets you sit it on your table in your tent. They call it a torch mode. And this is very definitely glare. You can't look at that little bulb on your mag light. Okay? So this is the most effective demonstration for people who don't have a picture in front of them. Okay? So just wear your mag light on your pocket and you can do this anytime you want. Okay? But this is what glare is. It's looking directly at a light when the light's supposed to be somewhere else. Another thing that you'll hear a lot about is something that we call trespass. Okay, so trespass is I produced light that I needed, but it then spills beyond the boundaries of my property. Okay, and so I have a neighbor right now. There's a ton of light trespass from his house in my property, and during the summer it's great. In the east we have deciduous trees, and I can't see his house during the summer. The backside of my trees do, but I can't. But in the winter it all comes over to my house. And so Niall and I have a long-standing conversation of, Niall, can we turn out the lights? He's like, oh, I forgot, right? But he has these fixtures on his house that send light from his house over to mine constantly. Okay? In many places where they have ordinances about lighting, this is a very deliberate word because there is legal meaning to the word trespass. And light trespass is a real thing, and it is in community regulations, and people do use it to protect their own property from other people's light. Okay? This picture is a picture from Chicago, and it shows that the most common perpetrator of light trespass is actually the city, right? So this is a house here, and this is a street light in Chicago, and you can see it's shining in the windows of this house. Okay, so this has come because we as a community want our streets lit up, but the city just went down to Lowe's and bought a light and put it on a light pole, and now it's shining in this house's windows. So I have a friend, she had one of this in her apartment, and so she called the city, and she said, there's a ton of light trespass from this street light outside, and the city was very responsive. They're like, we'll take care of it. Okay, so I went by her house, and the light pole's still there. And I'm like, McKenna, and she's like, oh, they fixed it. They came over, and they painted the backside of the light black. It fixed the light trespass, okay? And it was cheap, but they fixed it. Oh, no, on her side, yeah, it's still going the other side, yeah. Okay, so there are better ways to fix it, but they fixed it. And this is the point, right? You work with your community, you work with your local legislative bodies, and you work with your local public works, and they will work on this stuff with you. So anyways, so light trespass is a big thing, okay? And just like the case with glare, you want light in a particular place, and the problem is we just throw it up there, and it very efficiently goes everywhere, okay? So This is a picture of the city of Chicago. I wish I had a picture of the valley here. I don't. This was taken by a group of teens that we have at the Adler Planetarium. We have, I used to have one when I was in Montana and when I was in Utah, but we have in Adler a high-altitude balloon program called Far Horizons. So we basically take weather balloons and you tie iPhones onto them and you throw them up in the atmosphere and they take pictures. And then when it comes down, you go grab the iPhone and you have pictures of the city of Chicago. Okay, so what the teens have been doing is measuring from the sky the light in the city of Chicago, and then we go around on the ground and we measure it on the ground, and that helps us measure this diffusion that you and I were talking about. But you can see this is looking straight down on the city of Chicago, and because I can see all the individual streets, what that means is there are lights there pointing straight up. Okay? And I can't think of any reason we need to illuminate the undersides of airplanes flying into Chicago. Okay? But clearly we do. Okay? So if you just take this, we can count up this light. We know how bright they are. We know how efficient they are. We know how much electricity it costs. In the United States, $3 billion every year is spent on light, that is, on the electrical bill for the light that's going upward into the sky. That's a good use of $3 billion. Okay, that's $9 per person every year. But let's just bring it home, okay? There are 7.7 million people here in the state of Washington. So here in the state of Washington, you are spending $70 million a year on lighting up the undersides of airplanes. Do you got something you can use $70 million for that's not illuminating the undersides of airplanes, right? So this isn't even just preserving the dark skies. This is practical matters. We're spending money on energy that we're just throwing into outer space. And as we move forward, and this must be conversations you've had here in the Conservancy, and we start to thinking about energy efficiency and carbon footprints, this is a huge carbon footprint. And one of the ways to make progress on other things that we care about and simultaneously preserve dark skies is to work on this issue. Okay? So it's all interlinked, like everything is. Every natural resource system is connected to every other one. Okay? So this is always a great starting point when you're trying to convince your local authorities to let's improve our lighting practices. We're like, wouldn't you rather use that money for something else, right? Because they are spending that money on illuminating the night sky, which we'd rather them not do. Okay? There are tremendous impacts on the environment, and in areas where you're very close to nature and very close to the wilderness, those impacts from light are tremendous. Some of them you can read about this. There are long lists and long papers about this, like we don't care about sea turtles here in the middle of Washington, okay? Sea turtles care about this. But how many of you live on wetlands? So I live on a conserved wetland, right? So frogs and amphibians, their mating occurs at night. And if the wetlands are illuminated, like by my neighbor Nile, then they stop their mating calls, and it disrupts their reproductive processes, okay? Bird migration is hugely impacted by illumination. So birds, in particular, they tell the changes of the seasons by the length of the days. Okay, and so when they see constant light around, they don't know what season it is. They decide to migrate early. They decide to migrate late. And so as cities grow in illumination, it disrupts their migration patterns. Lots of birds also migrate at night. And so when they see lights in cities, it stalls them. Okay, so there's a very famous example from the Twin Towers Memorial in New York City. Has anyone seen that? So where the towers used to be, there's these enormous spotlights that they shine up in the sky. And they could see on radar that there were thousands and thousands of birds trapped, essentially stopped, in the vicinity of the twin beams because they didn't know it was dark. And so they're just stopping their migration and flitting around between the cities and stuff. And so they turned off the lights. They said, let's do an experiment. And it took 30 minutes, and the birds dissipated and continued on their way. Right? So we are unintentionally disrupting this kind of thing. We don't even know what's going on. If they hadn't have had the radar on, they wouldn't have seen the birds around the Twin Towers, around the memorial. Okay. It also disrupts predation and prey. So, most prey hunts in the dusk hours or during the daytime, and most predators, and most prey hides in the dark. And so if you're putting lights up outside, then it makes it very easy for the mountain lions to see the things that they would normally not be able to see in the dark. So there are a lot of disruptions to hunting patterns. This applies not just to real big predators, but also applies to things like bats, nighthawks, birds that hunt at night, all of those sorts of things. And then there's a whole slew of this stuff related to insects as well. Okay, and I don't know much about insects, so I didn't talk to you all about it. So, but if you go reading about this, there's a huge body of literature where the wildlife biologists are beginning to try and comprehend exactly what we're doing to disrupting all of these natural patterns in the environment. And in a place like this, where you're this close to nature all the time, you are going to see those patterns way sooner than we see them in the city of Chicago. Okay, because our wildlife is already disrupted. So. There's also deleterious effects on human health. Most of you are probably familiar with, or if you aren't, you should be, with the fact that there's considerable growing concern with our exposure to blue screens. Okay, so working on your computer late at night, sitting in bed, checking Wikipedia on your phone to settle an argument with your spouse, right? All of those sorts of things are exposing you to this kind of blue LED light from your phone. Okay, and so what that does is it disrupts the production of a hormone in your body called melatonin. Okay, melatonin is the hormone that controls your circadian rhythm, when you're tired and when you wake up, and that falling asleep cycle. And so if you're constantly looking at Wikipedia on your phone, then your body's like, whoa, I'm exposed to bright light. In particular, I'm exposed to blue light. That means I think it's daytime. I'm not going to produce the melatonin I need to make you go to sleep. Okay, so this is a kind of growing problem with the rectangles in our hands. It has been a problem in the context of cities for a long time because cities have kind of adopted this philosophy. We're a vibrant city if there's always a nightlife from 9 p.m. to 2 a.m. in the mornings, and so they've lit up the city streets in the same way, and so it has that similar effect that just staring at a blue screen does all the time. The thing that is apparently growing concern, okay, and there's lots and lots of studies are pointing to this. Initially, this was seen with shift work, so night nurses, people who are doing nighttime work in factories, is that we are seeing elevated cancer in those people. And increasingly now, as our society moves this way, we're seeing growth in cancer from people who are exposed to blue light. So we think there's some connection between the light exposure and the melatonin production that's related to cancer risks, okay? So there's a statistical connection. We don't know what it is quite yet. But this sort of thing is a growing concern, and unless we think hard about our lighting practices, then this is just going to keep getting worse, okay? But again, because we've seen the link, even if we don't know exactly what the link is, if the solution is reducing light, then this is that interlinkage that we were just talking about. If we protect ourselves from light, then we're also protecting our night skies, and this is kind of how we make progress on multiple fronts. Okay, so as we often say in this game, we meet people where they are. We have people who care a lot about this kind of thing, about cancer risk, exposure to light, what it does to human health, and if we work with them, then it serves our purpose to protect the dark skies as well. Okay, so lots of problems. What can we do? Right? This is always what it boils down to. Okay, and the single most effective thing you can do is you can shield lights. All of this is caused because we take light and we throw it out into the sky with reckless abandon. Okay, we use more light than we need, we don't put it where we want it, and any that's wasted we don't worry about. And so it trespasses on our neighbors, it goes up into the sky, it diffuses through our communities, and it erases all of those dark skies that we see in the rural parts of the country. Now, the dark sky folks here have this picture on a card, so you can take it with them. This is from an organization that is committed to dark sky preservation around the world. They have a lot of literature. I'll point you to them at the end. But what they show here is this is kind of the most common bad lighting practice that you see. It is a completely unshielded light, and there are steps you can take that are not great on this end, but also it's better than nothing, and they get better and better and better as you go to the right here. Okay, and so we have names for all of these. This is called unshielded. This here, where there's no light going up, but it can go horizontally, this is usually called full cut off. Okay, and then this is usually called full shielded. Okay, so you can see, and you can kind of recognize, you know, from the way we've drawn them, that there are different styles of lighting. You've probably seen some of them around town here, but every move you make towards this position we have here on your right is an improvement of what we're doing with light and how it will protect the dark skies above us. Okay, this kind of lighting improvement addresses a couple of different problems. And what it does is it provides an opportunity to change a bunch of other habits that we also have when we light the night sky. So in particular, if I'm lighting like this, the light's not being spread very effectively. And so usually the solution over here is to pick the brightest freaking light you can and put it up there, because that's how I get enough light down here on the ground to see whatever it is I want to see, my parking lot, whatever it is, okay? So the way to think about this is to imagine two light bulbs, okay? So in the olden days, most of you are my age, right? Light bulbs were ranked by wattages, right? So higher wattages were bigger numbers. Okay, so the way I represent brightness, the way we do this in physics class, is we draw lines. Okay, so for a 40-watt bulb, I'm going to draw a certain number of lines. Those are rays of light coming out from the bulb. And for a 100-watt bulb, I draw more lines because it's brighter. Okay, so when I need a lot of light on the ground, I put a really bright light here. Okay, and it puts a lot more rays down on the ground. But it also puts a lot more rays of light up in the sky where I don't need them. Okay, but if I shield my light, okay, if I shield that 40-watt bulb, typically we have the inside painted white or reflective silver or something. And so all of those rays from the 40-watt bulb that were originally going up are now going down. And so what I have here on the ground then is more light from a 40-watt bulb in the place where I wanted it. I've eliminated upward scattering of light. I've put the light where I wanted it, and I'm saving energy at the same time. Right? When you hear us talk about shielding, we often are just trying to get you to agree to do it, but there are many, many benefits from doing this simple thing. It's not just keeping the light from shining in my eyes, it also provides paths forward on the other problems that are associated with this. Okay? So I did this with my neighbor. So she had these fixtures. This is my other neighbor. She had these fixtures on the front of her house, and there's not a lot of trees between me and her. And so these were shining out over across our yard into my backyard where I set up my telescope. Now these are the fixtures I have on my house. These are full cutoffs. You can see these, right? So these I should have taken a daytime picture. They're very stylish, mod. They're black rectangles, but the light bulb's up in there and it just shines down. And so there's no light that goes horizontal over to her house. And I was like, Katrina, these are kind of shining in my eyes, and I can't take my telescope out. And the way I really did that was I brought her over to look through my telescope, and she's like, my lights are really bright. And I'm like, right, so, okay. So anyways, so she's like, is there anything we can do about it? And she's like, I really don't want kind of ugly fixtures like yours. My house is I was like, that's fine, Katrina, I get it. I didn't put these here. They were on, this is why I bought the house. It had nice fixtures, right? But she went to these fixtures, okay? So these fixtures are not completely transparent like her old ones. Okay, but they're open on the bottom, just like mine are, so they shed light down on her porch, okay? But because they are opaque, the glare going horizontally is much less than it was when she just had her transparent panes of glass, okay? And she loves them. They're very mod. They look cool, okay? But they did their job. It's not perfectly shielded, but it's also better than not being shielded. Okay? So we made progress, and she's very aware of the problem now. She helps me talk to Niles all the time because his light shines through my property to her property. Okay? But you know, this is the beginning. This is how you start conversations with people. Okay? And so Katrina and I have this very, very nice conversation and experience, and she's an advocate now. She understands what the problem is. Okay? So cities can do this kind of shielding on the street lights that you see around, but you can also do it in your own homes and in your own neighborhoods, and that's really the point. And part of the battle of dealing with light pollution is one person at a time. This is really grassroots. It means I do it, and it means I talk to my neighbors and they do it, and then they talk to their neighbors and they do it, and we talk to the folks at the Dark Skies Coalition, and you know, we slowly protect this very vibrant natural resource that we've grown so accustomed to here in the American West. Okay? Now, as we switch from incandescents to LEDs, there's another thing that comes up called color. And many of you may have experienced this. You know, it's not like the old days where they had neat names like soft white and you know all that stuff that we used to buy bulbs with. If you look on the sides of the box, they have these numbers, and there's some physics behind it. I'm happy to talk to all of you about it if you want to. But there are these kind of warm whitish colors, these kind of what we call daylight colors, and then these cool white colors. And I'm sure you've all experienced this. You went and you bought a brand new bulb, you put it in your bedroom, and you're like, oh my gosh, I can't read by this because it's this color, and I was really hoping it'd be something a little bit nicer to read with before I go to bed, okay? This number is not just about the lights in your house. It's actually about the lights outside, okay? And the lights outside, there is very strong reasons to use these lower color temperatures, the lights that look kind of yellow, not the lights that look glaringly blue. There's good biological reasons. There's good reasons related to the diffusion for go to these kinds of colors. And so when cities are engaging in transforming their lighting outside, in particular their street lighting, it's very important that they have a conversation about the color of the lights, because they invest a gazillion dollars in these kinds of lights, and it's not going to feel any better. It's going to be really bright in your city. If they invest in these kinds of lights, it will make much better progress in our light pollution goals. So this is a complicated subject. I don't want to talk about it at great length. I'm happy to talk to you some more. The folks at the coalition will talk to you more about it. But if you want to know about this more, I'm happy to talk to you about it. You should just be aware that it exists. Okay? It matters what temperature your light bulbs are at. Okay? Okay, this is related to the blue thing as well about the health issues. So, if you don't know much about how bad the light pollution is, one of the things that we need to do is we need to go out and collect data on it. Okay, so the maps that I was showing you is compiled from satellite data, but the thing that we're doing with our teens in Chicago is we're validating data from above with data measurements on the ground. Okay, and so you you still can buy devices to do this. This is called a sky quality meter. I meant to bring mine with me and I didn't. I'm sorry, I forgot that. It's about the size of 2 cell phones stacked together. And so you just go out, you point it at the sky directly overhead, you push the button, and it gives you a reading. Basically, it's measuring how much diffuse light is coming from directly overhead. Okay. These days, you can do it with your phone. So this is an app called Dark Sky app. I have it here on my phone. So what you do is you take, you start by just covering up the camera with your hand. So you take a picture of what total darkness looks like, and then you take it and you take a picture of the sky, and it gives you the same reading this does. Okay. So you can do it with your phone. Okay. And the important part of this is that if you really want to work on light pollution in your local community, you really want to have data to back you up. It's one thing to say, you know, my neighbor's light is shining in my window and I think that's a problem. Yeah, it's shining in your window and it's probably obvious it's shining in your window, but if you want your community to work on this, you need to be able to quantify in a very stable way how bad the problem is. You want to say, last year the light pollution was this, and this year the light pollution is getting worse. We need to control how we're growing, how we're changing our lighting. And the only way to do that is with real solid data. I sound like your physics professor in high school, but I'm a physics professor, so you should expect that, okay? Collect data, write it down in a notebook, okay? But the point is you and I live in the future. And it used to be scientists were the only people who could do this sort of stuff. But today you have a magic device in your pocket that lets you be a participant in this kind of science. Okay, and when you're talking to your city council, and when you're talking to your developers, and when you're talking to your schools or your libraries or the mall they want to build here or whatever, having solid information about what the skies are like is going to help you have conversations about the light pollution evolution here in the Matao Valley. I'll give you my scientist advice, but you can send me email or you can talk to the coalition folks, right? You can go out and do this, but you got to be a good scientist about it. So every time you do, take 2 or 3 readings and write all 3 of them down, okay? And then make sure you go back to the same spot and do it many different times. Do it, on a day when it's kind of hazy. Do it, on a day that's cold, on a day that's warm, because you want to know what's it really like, not what was it like on the day that I went. If you go out and measure it on the full moon right after a snowfall, it's going to feel like there's a lot of light pollution. Okay, so do it on many different days, take several readings, and be a good scientist about how you collect your data. Okay, and we can help you with that sort of stuff. So lots to do, easy things to do, kind of cool things to do when you're retired. You missed out on getting that astrophysics degree. This is a pathway to getting your astrophysics degree. I've had an undergraduate write your senior thesis about this. It's been done, so, okay. I always like to leave you with some things to learn more about yourself. So here's a couple of documentaries. This is called Saving the Dark, and this is called The City Dark. This one's a little bit older. This one's about 7 or 8 years old now. This one's about 3 or 4 years old now. They're both very good documentaries. They're about 90 minutes long. They go from places like Chicago out to places like the Matao Valley and show you how our civilization is slowly encroaching on this natural resource that we call the dark sky. And then they talk a lot about what do we do to protect it. Okay, so that's a good starting point. This book by Paul Bogard and this book by John Eckhoff, The End of Night and the Darkness Manifesto, both of these are about the slow erosion of the night sky. And they do it from slightly different viewpoints, but they largely follow ecological systems, what it's doing to the natural world around us, and at that interface between our civilization and the natural world. So you may find both of those books very good. Darksky.org, this is the what used to be called the International Dark Skies Association. They just rebranded. They're now called the Dark Sky. Sorry, I can't remember what the full name is now because it's always been the IDA to me, the International Dark Sky Association. But this is their website. There's lots here about the different issues related to light pollution. There's lots here about how to deal with lighting. There's lots here about how to talk to your neighbors if they have bad lights. There's lots here about how to talk to your city council. There's lots here about all sorts of stuff. So whatever your particular interest is, you don't have to know it all. You don't have to do it all. You have to be, I would like to improve my lighting practices at my home. These folks can help. You could be, oh my gosh, they just built a new school across from my neighborhood, and the lighting is horrible. What do I do about it? They'll tell you how to do that, right? That sort of stuff is all good starting points. Okay, the folks at the Dark Sky Coalition can help you as well. Okay? In fact, I have a couple slides from the Dark Sky Coalition folks. So let me just show you those, and then we will call it a day. So the Dark Sky Coalition is actually a group of people already active here in the Valley. Dean, wave your hand, Dean, so people can see you. Dean's here with us tonight. Tuck Stebbins, who's an old colleague of mine, is also on their steering committee. He couldn't be here tonight. But this is a group of folks here in the Valley who are thinking about this stuff in the ways that I've just been telling you about it. Okay, and so they have a lot of initiatives, a lot of things they're working on, ranging from collecting data, from talking to city council, from writing letters, all of that sorts of stuff. And if you talk to them, they will gladly put you to work on this issue if you feel passionate about it. As it says here, right, you live in one of the most pristine parts of the Pacific Northwest in terms of dark skies, as we've been talking. And so they really are committed to preserving and promoting that fact. And there's lots of good reasons beyond the ones that we've talked about to do that, and they are really at the heart of that. They're a part of the Matao Valley Citizens Council, so they're kind of connected already to your organizational structure here. So they do a lot of different stuff here. You can kind of see the list here of things that they're worked on, things that they've been involved in. You can see the shielding on the fixtures down here in front of the thriftway that were installed, and that's improves the lighting in very point-like structures and businesses here in the valley. And they have their own website here, so you can either write down the website, you can certainly scan the QR code, but there's a long list of things, just like the Dark Skies Association, that they can help you with locally. And certainly having local people with local contacts, people who have dealt with the local community and done this right here in the valley are an enormously helpful resource for you if you find you need to talk to someone about this or you want to get involved and do it. Okay? So certainly stop by the table there in the back and talk to Dean at the end. But I'm going to shut up now and say thank you so much for your attention, and I'm happy to chat and take questions for a little while afterwards. Okay.